Let's say a surveyor wants to carry out a research in a community. He wants to study the health status of the community, and the total population of the community is 1000. For him to survey one single individual, it will take him 1 hour. And if he wants to survey all the individuals, that is all 1000 of them, it would take him 1000 hours, which is a long period of time. The surveyor does not have 1000 hours to give to his research. So, what he does instead is that take a small piece of this population of the community and then study that small piece. This is what I mean. So, the population of the community is 1000, and let's say it's represented with the help of people that I have drawn right here. What the surveyor does is that take a small chunk of this population and then study this small chunk. This small piece of the actual population which the surveyor uses for study and which represents the actual population of the community is what we call a sample. So again, what is a sample? A sample is a small piece of population which represents the whole population. And the process by which a sample is acquired is what we call sampling. There are various techniques of sampling, and that is exactly what you are going to learn in this particular video. There are two major types of sampling techniques. They are random sampling and non-random sampling. In random sampling, each and every individual of the population have equal probability of getting selected. That is, let's say in this particular community, the total population is 1000. That is, there are altogether 1000 individuals. Each and every individual have the equal probability of getting selected. That is 1 out of 1000 probability. And that is why random sampling is also called probability. It's also called probability sampling. Since each and every individual have the probability of 1 out of 1000 to get selected or equal probability of getting selected, they have an equal chance. So everyone gets an equal chance. And since there is no favorism that exists in the individuals, there's no biasness as well. However, in case of non-random sampling, since the individuals are not randomly selected, few individuals have a higher probability of getting selected as compared to other individuals. That's why it's also called non-probability sampling. And since the probability is not the same for all to get selected, there is also no equal chance. So basically, there's an unequal chance of selection for all. And finally, since favorism exists, biasness exists as well. Again, one last time. In case of random sampling, each and every individual of the population get an equal chance of getting selected. That is, each of them have equal probability of getting selected. However, in case of non-random sampling, few individuals are favored over other individuals. That is why ones that are favored have a higher probability of getting selected over other people. So which one would be the better method of sampling? Obviously the one where everyone has equal chance. Because in that case, there would be the least amount of biasness and highest amount of representation of the population. So obviously random sampling is superior to non-random sampling. Here are some of the random or probability sampling techniques that you need to know for exam. Number 1, simple random sampling. Number 2, systematic random sampling. Number 3, stratified random sampling. Number 4, multi-stage random sampling. Number 5, multi-phase random sampling. And number 6, cluster random sampling. Under non-random or non-probability sampling, you have to know number 1, convenience sampling. Number 2, quota sampling. Number 3, snowball sampling. Number 4, clinical trial sampling. And number 5, purposive sampling or judgmental sampling. I got the spelling wrong. Okay. So first we are going to look at the various types of non-random sampling or non-probability sampling. Let's say this is the population to be studied by the surveyor. The best method of surveying this population would be to choose individuals or representatives at random and then use these representatives for study. However, for that, the surveyor requires a population list so that he can choose individuals at random from that population list. But let's say the population is not present with the surveyor. Then the surveyor chooses convenience sampling as the sampling technique. As the name suggests, in convenience sampling, the surveyor chooses individuals or representatives as per his convenience. So the important term is convenience. So the surveyor chooses as per his convenience. And in this particular condition, the most convenient for the surveyor would be to choose the people or to choose representatives that are closest to him. So, does this create an equal chance for each of the individuals? No, it does not, because the individuals closer to the surveyor have a higher probability of getting selected as compared to individuals that are farther away from the surveyor. The closer the individuals are, the higher chance of them getting selected. So, there is an unequal chance of selection. The advantages of this technique is that, so the advantage is that it's cheap, it's easy, and it's fast. However, there's a huge disadvantage, and that is there is an unequal chance. Unequal chance. What happens when there's an unequal chance? When there's an unequal chance, the sample comes out to be highly unrepresentative of the actual population. And for a better sample, we require high representation. So we have a community of 400 individuals, and the surveyor wants a sample of 40 individuals. In case of convenience sampling, the surveyor would simply reach out to the individuals that are easily approachable. That creates an unequal chance for the individuals. That is, the individuals that are easy to approach have a higher probability of selection, and the individuals that are less approachable would have lesser probability of selection. In case of quota sampling, instead of simply reaching out to individuals, first the whole population or community is divided into smaller subgroups. And we call these subgroups strata. Strata. Okay, once more. So first you have your population. The population is divided into smaller subgroups. We call these subgroups strata. Now, the researcher goes to each of these strata and carries out convenience sampling. So instead of directly carrying convenience sampling, first the whole population is divided into smaller strata, and then convenience sampling is carried out in each of these strata. So the researcher goes to first strata, carries out convenience sampling, and let's say collects a sample of 10 individuals, then goes to second strata, again carries convenience sampling and collects 10 individual, goes to third strata, carries convenience sampling and collects 10 individuals, goes to fourth strata, and finally carries convenience sampling to collect 10 samples. The reason it is called quota sampling is because the surveyor has to fulfill a certain quota in each of these strata. For example, the surveyor, after he went to first data had to collect a total of 10 samples, and that 10 right there is the quota to be fulfilled. Snowball sampling is a non-probability sampling that is carried out for hidden population. So it's carried out for hidden population, or you can also say it's carried out for population that is difficult to reach. Difficult to reach population. For example, IDU or injectable drug users. Let's say you want a sample of injectable drug users. If you go to general public and try to search for injectable drug users by simply asking who takes injectable drug, you want to be able to find sufficient number of people for your sample. But if you somehow find one single individual that take injectable drug, you can ask this individual to tell you other of his friends that also take injectable drugs. So basically, the first research participant helps the researcher to find other participants for the sample. So the first participant helps to find other participant. The other participant further finds other of their friends, other friends who also take injectable drugs. Then these participants, they also help to find other people who also take injectable drugs. And that's how the researcher finds a sample that is big enough for his research. The reason it is called snowball sampling is because it shows a snowball effect. When snowball rolls, it picks snow with it, along with it, and the snowball grows larger in size. Similarly, in this sampling as well, first the surveyor finds one single individual, then the first individual or participant helps the surveyor to find other participants. These other participants, they further help to find more participants. In purposive or judgmental sampling, the researcher carrying out the research has a purpose. So the researcher has a purpose. In order to fulfill the purpose, the researcher selects participants for the sample by using his own judgment. So the researcher passes judgment to select the participants that are required. For example, let's say the researcher wants to know about tires. Since the researcher has a purpose, that is to know about tires, the researcher tries to select people that know about tires, and the researcher passes his judgment to select mechanics in a community since they know best about tires. So the researcher has a purpose that was to know about tires. In order to fulfill the purpose, the researcher himself select people that know about tires like mechanics in a community. Next is clinical trial sampling. Clinical trial is carried out to check the safety of a drug that is to be released in the community. And usually the trial is carried out in four different phases. For trial to be carried out, participants are required. Let's say in first phase, participants are required, and the sample of participants need to be 100. So these 100 participants, they are not selected at random in the community because that is not possible. Instead, they are selected as F. Instead, they are selected as FCFS. That is first come, first serve. Let's say when you become a participant, you may get some cash or you may get whatever benefit is associated with the trial. So people who are interested to become the participant will join the clinical trial. And the first 100 people to join the clinical trial will be selected as the participant for the trial. So the first 100 to come will be the first 100 to serve. Let's look at the various types of random sampling or probability sampling, which is superior to non-random sampling or non-probability sampling, cause in random sampling every individual has an equal chance of selection, making the sample highly representative of the actual population. Let's say we have a community right here, and the surveyor wants to study this community. The population of the community is 400, and the sample he requires needs a total of 40 individuals from these 400 people. The surveyor wants to study the status of diabetes in this particular community. Let's say if the surveyor applies convenience sampling, that is, he reaches out to the community, people of the community that is most approachable for him, then the people that is going to be included in his sample is going to be majorly the red people. The reason I have shown them with red is because these people of this particular locality of this community have a higher prevalence. They have a higher prevalence of diabetes due to some genetic reasons. So you have this community right here. In this community, the red people are a part of a certain locality within the community, and in this locality there is a higher prevalence of diabetes due to some genetic reason. If the surveyor applies convenience method, then he would get most of his sample individuals from this locality right here. That would mean most of his individuals in his sample would be diabetic, and the status of diabetes from his study for the community would come out to be higher than it actually is, making the sample highly unrepresentative of the population. So instead of applying convenience method, which makes the sample highly unrepresentative, it's best to choose individuals at random. And the simplest method to do that is simple random sampling. In simple random sampling, as the name tells, you simply choose participants at random by applying various methods. One method is lottery method. So the first method is lottery method. In lottery method, you simply get a bucket, put household numbers within the bucket in the form of chits, and then pick these chits. Let's say you get this chit right here and it says 91. Then the household number 91 now becomes a part of your sample. Next method is random number table. Random number table. As the name says, it's a table that contains numbers at random, and from this randomly written number, you can start picking up household numbers. So let's say you choose the first two numbers and it comes out to be 01. Then that's the household number for your sample. You don't pick the next two numbers. Instead, you pick the numbers after the next two numbers, that is 56. Now 56 is your household number that becomes a part of your sample. In that way, you can randomly choose house numbers that can be a part of your sample. But the problem is, let's say you use random number table and the household numbers that you get are 01, which is basically 1, 56, then again remove 7 8, you get 90, remove 00, you get 67, remove 89, you get 21, and so on. There is still a possibility that all these household numbers have majority of household numbers that still fall under the red locality. And if majority of household numbers they fall under red locality, then after survey the status of diabetes is going to come out to be higher in the community than it actually is. That is why you carry out simple random sampling for homogeneous community. For homogeneous community, simple random sampling is best, but then simple random sampling should not be carried out for heterogeneous community. So next we have systematic random sampling. In systematic random sampling, participants are chosen by using a system but at random. And this is how. First, to carry out this sampling, you require a household list. So right here I have a list of all the household that is present in the community. In case of random sampling, you'd start randomly picking household numbers from this either by using lottery method or by using random number table. However, in case of systematic random sampling, you need to use a system, and this is what you need to do. So first, the population of the community is 400. You require a sample of 40. You first need to find out the sample interval. Sample interval. This is the system I'm talking about. Sample interval equals to total population divided by your desired sample size. Desired sample. Total population is 400, which is divided by 40, which comes out to be 10. So sample interval comes out to be 10. The significance of sample interval is that now every every 10th house is selected for the sample. So in this case, a system has been used in order to choose the participants for the sample. Now, how is it that we make this random? We make this random by selecting the first house using simple random sampling or randomly. So you choose the first house randomly, and after the first house has been chosen randomly, you will start choosing the every 10th house after the first house. Let's say you applied lottery method to choose the first house and it came out to be house number 3. Now you'll start choosing the every 10th house after house number 3. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So now 12 is selected. Again, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. 21 is selected and so on. So a system has been used, that is sample interval has been used, and randomness has been used by selecting first house applying simple random sampling. That's why we call it systematic and random sampling. Stratified random sampling is the best sampling technique that is used for a heterogeneous community. In stratified random sampling, first stratification is done by the surveyor. That is, the heterogeneous community is divided into strata or subgroups that are homogeneous. So basically, heterogeneous community is divided into homogeneous strata or subgroups. So we have altogether right here 1, 2, 3 strata or subgroups that are homogeneous. The community itself is heterogeneous, but the individual subgroups they are homogeneous. Now, the surveyor reaches out to each of these strata, strata 1, strata 2, and strata 3, and in each of these subgroups or strata, the surveyor carries out SRS, either simple random sampling or systemic random sampling, making the sample highly representative of the actual population of the community. Stratified random sampling is similar to quota sampling if quota sampling was done randomly. This is what I mean. So you have quota sampling and stratified sampling. In quota sampling, the whole community is first divided into strata, and then on this strata, convenience sampling is done. That's why it is not random. In stratified sampling, the whole community is divided into strata, and then to each individual strata, simple or systematic random sampling is done, making the sample random and highly representative. One extra concept in stratified random sampling is that from each of these subgroups, if we select the number of individual at proportion, that is, let's say the population of red group is 100, so we choose a sample of 10 from there. The population of blue group is 200, so we choose a sample of 20. What I have done here is chosen the number of individuals by simple random sampling from each subgroup as per the size of the population. Since the size of the population of red group is 100, I have chosen 10. Size of the population of blue group is 200, so I have chosen 20. So the number of individuals for the sample has been chosen proportionate to the population of the subgroup. And this technique that we have applied is what we call PBS, or probability proportionate sampling. Again, PBS, or probability proportionate sampling, where the sample size is proportionate to the population of the subgroup. In multi-stage random sampling, sampling is done at multiple stages, and to each stage, randomness is applied. This is how it's done. Let's say a surveyor requires a sample of 20 villages, and he achieves his sample by doing this. Firstly, the surveyor has the country. Let's say the surveyor is in a country that has 7 provinces. Out of these 7 provinces, the surveyor selects a total of 2 provinces. This is stage 1. In stage 1, the surveyor selects 2 provinces out of 7 provinces. Then in next stage, the surveyor selects 2 districts from each province. So 2 district each. 2 district each. That is from one province, 2 district, from another province, 2 district, a total of 4 district. So this is stage 2. Again, the surveyor chooses, or the surveyor selects 2 villages each from each district. So 2 villages each. So from one district, 2 villages. This is stage 3. Finally, the surveyor has selected or collected 2 into 2 into 2. 2 to the 4, 4 to the 8, a total of 8 villages. 2 province from 7 province in stage 1. 2 district in each province in stage 2. 2 times 2, 4 district. Then 2 villages from each district in stage 3. So 4 times 2, 8 villages in total. So since the sampling has been done in different stages or multiple stages, it's multi-stage sampling. And we make it random by applying simple or systematic random sampling at each stage. In multi-stage random sampling, sampling was done in multiple stages and randomness was applied to each of these stages. In multi-phase random sampling, sampling is done at multiple phases. This is how. Let's say a hospital carries out a tuberculosis survey. The survey is carried out in a day. So the total patients that the hospital receives in a day is what becomes the part of the survey. Let's say the hospital receives a total of 12,000 patients a day. Out of these 12,000 patients, a total of 6,000 patients are selected for the survey in first phase. This is the first phase. Out of these 6,000 patients, Montauk's test is carried out. Montauk's test is carried out. Out of 6,000 patients, only 1,500 patients, they show positive Montauk's test. The rest that show negative Montauk's test, that is 6,000 minus 1,500, whatever comes out, is removed from the survey. This falls under second phase. Again, sputum smear test is carried out. Sputum smear test. From 1500 patients, a total of 500 patients, they show positive sputum smear test. The rest show negative sputum smear test. So they are removed from the survey. This is under third phase. Finally, out of these 500 patients, a total of 200 patients are selected, and this comes under fourth phase. So in this process, sampling is being carried out in multiple phases. And in these phases, the patients that show negative test are removed from the sampling process. Now the question is, how is this sampling process made random? It is made random by carrying out simple random sampling or systematic random sampling at first phase and at last phase. So the difference between multi-phase and multi-stage random sampling is that in multi-stage random sampling, sampling is carried out in multiple stages, and in each of these stages, simple or systematic random sampling is carried out. However, in case of multi-phase random sampling, sampling is carried out in multiple phases, and simple or systematic random sampling is carried out only in first and last phase of the sampling process. Technique of cluster random sampling is used for checking the immunization coverage in a community. Immunization coverage in a community. And this is how it's done. Let's say we have a community right here which is to be checked of its immunization coverage. First, this community is divided into multiple clusters. Let's say the surveyor divides this community into a total of 500 clusters. Then from this 500 clusters, a total of 30 clusters are chosen. To make it random, SRS, systemic random sampling, is applied to choose 30 clusters out of 500 divided clusters. Then the surveyor goes to each of these 30 clusters. So let's say this is one of the 30 clusters that has been chosen. The surveyor goes to the middle of the cluster and starts moving away from the middle. Starts moving away from the middle until when? Until the surveyor finds 7 children. Until the surveyor finds 7 children. So from each cluster, 7 children is chosen. That is, from 30 clusters, a total of 210 children are chosen. In this case, random sampling is not possible. Instead, first come, first serve is applied. That is, the first 7 children that the surveyor finds in the chosen cluster are the ones that are going to be the part of the sample.